All right, today we're going to talk about section 8.4, adjacent and vertical angles. And what we're going to be looking at is when lines intersect, they form angles. So whenever there is lines intersect, they can intersect in three ways. So we're going to write intersecting lines, intersecting. And they can do, we call them, they're either intersecting, they can be perpendicular, or they can be parallel. Well, parallel isn't really intersecting, but it's still important and fits in with this situation. Intersecting lines will look like this if I have two lines. And pretty much any possible direction that they can intersect, we just refer to them as intersecting. However, there's a specific kind, and when lines intersect like this, they make a bunch of these little angles that are all around them. And that's kind of the key to this section, and that's what we're going to be focusing on. Now, a perpendicular line intersects a little different. It looks, what color do I want to use? We'll use this one. Perpendicular lines intersect, and when they do so, they make a right angle. And if one of these is a right angle, actually all of them are going to be little right angles, and they are perfectly square. So that's what we call perpendicular. And parallel are lines. They're not really intersecting lines, but it'll come up in the homework will ask about it. They look like this. And they are the one kind of line that if they're on a plane, so they're kind of on this page, and they will never intersect. And the way that I do that is I put a little arrow to show that they will be traveling along this page forever if I kept extending this out. Now, I'm sure I didn't draw mine perfectly, but if I did, they could kind of go forever and never intersect. Almost like if they were like railroad tracks. It's the same idea, where railroad tracks would be perpendicular, because if they intersected, the train would fly off the tracks and then all the people would die, and that would be really bad. So that's why we need things that are parallel. However, when we have lines that intersect, we have adjacent and vertical angles and really cool things that can happen about that. Okay, so let's draw our little diagram. And we have our intersecting angles. Now, this is a bad diagram because it looks like kind of perpendicular to me. So in this case, it's not going to work, but I'm going to draw a second diagram, hopefully yours is better, that will look more like this. And this is the one that I really meant to draw. And if I do this, I can see that I would have 1, 2, 3, and 4 total angles. And what I can do is I can have adjacent angles and vertical angles. So let's write our little definition for what those are below. We have an adjacent angle. And those are angles that are next to each other. And these angles, their sum is always 180 degrees. We also have vertical angles, which I call opposite angles. Vertical angles. And these angles across from each other, and they are congruent. Okay, so let's look what that means up here. That means if I have my angles here 1 and 2, I could write angle 1 plus angle 2 equals 180 degrees. And that I know to be true because they are adjacent angles. So this must be true. I can also see that my angles 3 and 4 are also adjacent. They are next to each other. So I can write angle 4 plus angle 3 equals 180 degrees. And I know that to be true because they are next to each other. Now, however, I can also write it like this. I can write that angle 4 plus angle 1 equals 180 degrees, because I can see that these two here are both along this line, and I can look at it sideways, and I can also write my last one. Now I should have left more space, but I'll go above, and I can say that angle 2 and 3 equal 180 degrees. And this is actually going to be very helpful for us because later they will give us a diagram with some of these labeled and some of them not, and we'll have to use what we know in order to solve the missing angles. Now, I can also say, using my vertical angle idea, that I can say that angle 1 and angle 3 are equivalent. Angle 1 equals angle 3. And if you look, it kind of makes sense that when you look across, those two angles would be exactly the same. I can also say that angle 4 and angle 2, angle 4 and angle 2 are equivalent, or in this case, congruent. We usually use the word congruent, in this case, because congruent fits more with geometry and shapes. Congruent means equal in all possible ways and sizes and shapes and sides, whereas equal can often mean just equal in one respect. So we use congruent when we're talking about geometry instead. Now I want to do a couple of examples of things that they may ask you to do in this case. And I also want to take a look at how these parallel lines can kind of affect what we're looking at. All right. Let's take a look at an example here. And I have a line like this. And I have two lines here. Now, unfortunately, our book does not give the little parallel line marker, which I really like. So in our book's case, if they look parallel, you can trust them to be parallel. What we'll often do is we'll say, they'll give us some information, like this angle here is 80 degrees. And they'll say, what is angle J? Okay, well, how do we possibly get from this angle up here to this angle down here? Well, we can use another property about our perpendicular and, our parallel lines. And that is, with parallel lines, if I have a parallel line up here, every angle marker on this set of angles is going to be exactly the same as the one below it. So I can say that if this angle is here, this is 80 degrees, and this angles are down here, and these two lines are parallel, I can say this angle is also 80 degrees, because these two sets are congruent when they're perpendicular and when they look like this. Well, that's really easy and kind of convenient for me, because now it's very easy for me to figure out what angle J would be, because I can use my theorem that I made before, my adjacent angles, and I can say, well then, this entire thing has to be 180 degrees. So I can say 80 plus angle J equals 180 degrees. A little bit of algebra. Oops. And I can say angle J equals 100 degrees. And I can use that by taking a look at all of the little things that I'm using. Now remember that these parallel lines are true. Let's take a look at one other example. This one's a little bit easier, but the idea is that you're going to have to be using a lot of these tricks to figure out what they're trying to ask. This one, a little simpler. In this case, they're going to say that this angle here is 70 degrees. And what is angle M? Well, this one is going to be easy because I can know that angle M, using my vertical angles or opposite angles, angles across from each other are congruent. So this is 70. That must mean angle M is 70. So angle M is 70 degrees, which is pretty easy and kind of easy to think about. So you've got your angles of your parallel lines. Let me see if there's a way that I can write that a little bit easier. But with our, I can't find one that I really like. With our parallel lines, I can angle sets in parallel lines are congruent. Actually, this should be corresponding. That means if I have an angle here, it's going to be equal to this angle. Sorry. If I have an angle here, it's going to be equal to this angle. But this angle isn't going to be necessarily equal to any of the other ones in this set. But the corresponding angles of the angles in the same areas will be the same. So just to illustrate that one last time, say I have another set of parallel lines. With a line that goes between them. And I can label my 1, 2, 3, 4, 5, 6, 7, 8. I can say that my corresponding angles, which are the angles that are in the same spot on both sides, so I can say that angle 1 equals angle 5. I can say that angle 1 equals, angle 2 equals angle 6. Angle 3 equals angle 7. And angle 4 equals angle 8. And once I can match across, then I can use my vertical and adjacent angles to figure out what is equal to what, kind of as we go. And that's pretty much it. Good luck on the homework. There's a little bit of thinking involved. If you get stuck, ask a friend or ask a teacher.